Hello guys, so today we are here to solve our lead code challenge for the day. This is an array tree post order traversal. In this problem, we are given the root of an array tree and we have to return the post order traversal of its nodes value. Okay, so an array tree, what do we mean by an array tree? A tree which is having n childs. Okay, so this is an array tree. Okay, and then we have to do post order traversal. So in post order traversal, we first go down the childs. So go to the first child, then discover all its children. After finishing the first child, we go to the second child, then the third child, and discover all its children's. So we go to the childs and go to their childs, so children of the children, and discover all the children's of the children, and then to the second child and discover the second child's children, and go to the third child and discover third child children, and at the end we go through the root. So post order means we process the root at the end. This is the most significant thing about the post order. Okay. Now to solve this problem, what we will do that, first of all, we will check, this is mandatory check, that if root is equal to null, then what we will do that, we'll just return the new empty array list. Okay. Okay. So this empty array list. But, you know, it's better that we initialize this array list on the previous line. So list of integer result is equal to, not needed, but it's okay, new. So now we are, if the root is null, we are just returning the result. Otherwise, what we'll do, we'll call this post order, pass this root and pass this result, and let this post order, populate the result. And at the end, we'll just return the result. Okay. And here what we'll do, private void post order. And in post order, what we will do, we will take the root and list of integer, which is aptly named as result. Now in here, what we will do that we'll have to check if root is equal to null. When this will occur, when we go beyond the leaves. When we go beyond the leaves, then we just return. We don't want to go further. Okay. And when we are within the internal nodes, then what do we do? We 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 call, so let's do for, and so first of all what we do that we take the, because the children of a node, because it's an n-ary tree, the children of the node could be, you know the root could be a list of nodes. So root dot children could be a list of nodes. So we'll write this as list of child nodes. Okay. Okay. So this is the list of child nodes. And then we will iterate over each node, list of child nodes. Okay. And then what we will do, node list of child nodes, recursively we will call, okay, recursively we will call node, node and result. Okay. And at the end, what we'll do, list dot add result. It's not list. Re result dot add node dot val. Okay, like this. Okay. So see, we are processing the child nodes first, and then at the end we are processing the root node. So this root node is root. Okay. Yes. So we are at the end we are processing the root node. Okay. So children are processed first, and that is what, what do we mean by post order traversal? So let's run this. So this is one way to solve this problem. Is there any other way also to solve this problem? So I think, we can use, since it is a recursion, we can use stack to, mimic this recursion. To use stack, what do we need to do? So same thing, what we will do that, we will initialize a list of integer and name it as a result is equal to new array list. Okay, if root is equal to null, we will return the result. Okay, otherwise what we will do a deck of integer. We'll name it as stack. Okay, and it will be new array deck. Okay, and then in this deck, since root is not null, we will do stack dot push of the root. After doing this, we will go inside a while loop. In the while loop, what we'll do that, if stack dot is empty, okay. So if it is empty, then we can't do anything. But what we want is that stack is not empty. Okay. So when stack is not empty, it means that there are some nodes in it. Okay. Stack will contain the nodes. So I have to take the type of the stack as node. Okay. Deck of, okay. Now stack will contain some nodes. Now once this node is there, okay, what we can do that, we can inside the while loop, what we can do that, we can take this node and mark it as current node, and then stack dot pop. Okay, stack dot pop we can do, and list dot add. So we are putting this in this result, re result dot add current node dot, so current node dot val. But see, the thing is that we are doing post order. So if you are adding this result at, at the, so by default, this add method of the linked list of the array list will add some value to the end of the list. But if we add it to the end of the list, this will, not be the post order, because then this root will be at the front of the list in the final result, and which is not, what do you mean by post order traversal. So to enable post order traversal, what we will do that, we'll make it as 0, so that every time we are adding something to the result, we are adding it to the 0th index. And as we are adding it to the 0th index, the root node, this first time, when the first time this, while loop is being executed, the root node will be, at the 0th index. But after, for subsequent iteration, the root node will be, pushed from 0 to 1, because new thing will be coming to occupy the 0th index. And as new things will come to occupy the 0th index, finally what will happen that the, first, the root node value, the first initial root node value will be relegated to the last index of the result. And that's how we are able to, solve this problem. So result is added, and then what we will do that, we'll go to the, for node current node dot children. Okay, so we'll go through this, and then in the stack dot push of node will do. Okay, and at the end, what we will do that, we can just return the result. Okay, like this. So let's run this. Perfect. Perfect. This is a little on the slower side, but since we are adding it to the zeroth index, this is kind of, because every time we are adding something to the zeroth index, we have to copy, the content of the list, from that position onwards to a new list, and then that is being, slowing the things down. So can we, do something about it? So see, the purpose why we are adding something to the, to the zeroth index is that, when we are finally we are, returning something, it should be in the correct form. The root should be at the last index. We can achieve that, you know, because since we have entered the root first, since we have, this current node at the first iteration is having the root node, is the root node, correct? And we have entered this root node in the list at the first iteration itself. But since you are entering things at the zeroth index, this root node will be relegated to the last index. Okay. So can we mimic this movement? Yes, we can mimic this movement by using a stack. So by using a stack here, using a second stack, we can mimic this movement of the root node. Okay. So like this, we can, do this problem. So let's, do it once more. Okay. Let's, let's, reset this code. And with our own idea, we will again go through this solution. So what we will do that, we'll list will declare a result. List of integer result is equal to new array list. Okay. If root is equal to, if root is equal to null, we'll be returning the result. Okay. When if root is equal to null, we'll be returning the result. Otherwise, what we will do that we will take a deck of node and declare the stack one, okay, is equal to new array deck, okay, and then we have a deck of node stack two, okay, is equal to also new array deck. So like in the previous, like we were, storing the stack one dot push. So we are pushing into the root, in this the root, and then while stack one dot is empty, while stack one is empty. So we want not empty, because when it is not empty, then only we can, go inside it and, pull out the things from the front. So once we pull out things from the front, so it will be node current node is equal to stack one dot pop. So pop will remove the, top of the stack, and then we are adding this to the stack two dot push, and then we are adding this to the current node. We are adding this, okay, current node to the stack two, and after we have added this current node to the stack two, uh, we are initializing. So what we will do that in the same way for what we have done previously, node child of the current node dot children, okay, this current node dot children, and then stack one dot push, okay, dot child. So this will be, for subsequent, post order traversal, we are pushing the child node, and after pushing the child node, we are, saving this, from whatever we are copying from the stack, we are saving it in the stack 2. After this, what we will do that, if while stack 2 dot is empty, because we need to, pop from the stack 2. So what we'll do that, we'll do not empty, and then what we'll do, result dot add of stack 2 dot pop dot val. Okay, yes, and at the end we will just return the result like this. So this is also one more way to solve this problem. I hope, see, earlier we were inserting things into the list, into the result list, like result dot add at the 0th index. So at the 0th index, what does it mean to add it at the 0th index? We are just mimicking the behavior of the stack. Okay, we are adding something to the top, that is at the 0th index, the point where we can, insert the things. Okay, let's say this is, okay, current node result dot current node dot val, like that we were doing. Okay, but here what we are doing, we are putting it into the stack, and that is what is reversing the things. At the end, we are just, getting the things from the stack. So we are adding the result into the list, the content of the stack from the top. So the root will be at the last index, and that's how we are getting the root at the last. So if we run this, perfect. Now, one more idea has come to my mind. Let's try to do that as well. Okay. So again, we will declare the, list of integer result is equal to new array list. Okay, like this. And then what we will do, if this is, mandatory part, because if root is null, why go down the, why do full processing? We can return it from here itself. Now what we will do that, we'll declare one deck of node, name it as a stack, because it will be mimicking the behavior of the stack, and it will be array deck like this, and then stack dot add we'll just add the root. After we have added something to the root, what we'll do that, we'll put a check in the while loop that if the stack is empty. So if the stack is not empty, what we will do, we will do this. If the stack is not empty, we will, the stack is not empty, then uh, we will get inside the stack and pop the value, and whatever node is there, we will, loop through it, because a node can have n number of children. So we'll have to loop through its children and add them back to the stack. So that's what we are going to do. So to do that, we'll take this current node reference. In this, we will do stack.pop. So whatever is the content. So right now we have just added at line number 25, the root. So that root will come out. And for that root, what we will do that, we'll do node. Okay, and then current node dot children. So this children will be returning a list of nodes, and we will be going through that list of nodes and then adding it to the, okay, here we have to add it to the list dot result dot add result dot add result dot add mm, current node dot val. So this will be making it little faster, and then stack dot push of node like this. And then what we will do, mm, after this result is added, we will declare one new mm, mm, so let's not name it as result. We'll just leave it as a list. This will be a list. And then here what we will do that we'll declare one list of integer. This is the result is equal to new array list. And then we will go through this for int I is equal to what is the size of the n is equal to list dot size minus 1. So this is the last index. So I is equal to n. I is greater than equal to 0, and then minus minus I. Okay, like this. So result dot get of I, and we will list dot get of I, and whatever we are getting, we will be adding it to the result. Okay, and then at the end we'll be returning the result. Yeah, so we have to change this list. Perfect. Perfect. So here we are adding to the back of the list, to the back of the list, and we are reversing that list to get the result like this. So this is also one way to solve this problem. I hope things are clear and now it's easy. So let me know if you have any doubt. I'll definitely try to uh, fix those doubts. So thanks a lot.